In today's activity, you are going to look at not only how protein synthesis happens, how information from DNA gets transferred to mRNA and proteins, but what happens if there is a mutation in that DNA. So just want to review a little bit, because the first step you're going to do is they're going to give you a strand of DNA, and you're expected to write the complementary mRNA strand. So just to review, anytime there's a C, we know that in mRNA there will be a G. Anytime there's a G in DNA, we know there's a C in mRNA. Now, this is where things are different than what we talked about in the previous section. Anytime there's an A in DNA, U is the complementary base for it. However, anytime there's a T in DNA, an A is what is a complementary base for it. So the first thing you're going to do is write the complementary strand to your to the DNA molecule, which are your mRNA codons. So if we read these three at a time, that's what we call codons. And this process here is called transcription. Once we've looked at our mRNA strand, we're now going to read those three letters at a time and figure out which amino acids go in which order. So if you notice, our first codon in this example is GCU. So if we go to the codon table here, we see the first base is G. So I know my answer is somewhere in this row. The second one is C, so I know my answer is somewhere in this column. So that means that it's going to be one of these four. And as you can see, it actually doesn't really matter what the last one is, because all four are the same. But just to stick with it, the last one is a U. So it would actually be this one if they were different. So our very first amino acid is ALA, which is short for alanine. So let's try the second one now. So if you'd like to try this yourself first, you can pause it and then come back and listen to the explanation, and I'll do one more with you all. So our second codon is GGA. So if you notice again, here's G, here's the other G. So that means that it's somewhere in this row, somewhere in this column. So where those two intersect, that means the answer is somewhere here. And again, notice all four are the same. So it actually doesn't matter what the last letter is, but GGA, it would be this one right here. So our second amino acid is glycine, GLY. So you're going to keep doing this till you get to the very end. And this will be your original DNA strand. So once you've completed your entire original strand and your original amino acid, you're ready to look at the first mutation. On today's activity, you have four or five other mutation examples to look at. So here I have the original that we just did, no mutations. And now I have a mutation. And so you're going to be given a DNA strand that has a mutation, and so you have to figure out what that is. So if we notice here, what's different is this G was a T, so the wrong base got put in there. So because the wrong base was put into that DNA strand, that means when we go through transcription, we're going to have a C here instead of an A. And so that may change the amino acid. So if we look at the table, GCC, here's G, here's C. This is one where even though there was a change or a mutation, notice the amino acid is exactly the same. So the other thing it asks you to do, or it asks you for, is for you to circle what kind of mutation it is, and what was the impact. So the type of mutation, so this is what's called a substitution. And so we just substituted one base out for the other. So that's what you would circle if yours is like this. And what happened, there was no change as a result of this, because we ended up, everything else was the same.